Hello, my name is Benjamin Bailey, and I am a senior undergraduate student in the Chemical Engineering Department at Wayne State University. In this video, I will be introducing my work on the development of coacervate materials for the efficient coacervate extraction of cationic industrial dyes from wastewater. So first, I will give a brief background on the dye industry, environmental issues caused by synthetic dyes, and conventional methods used to treat dye-containing effluents. Synthetic dyes are used in a wide variety of industrial sectors, including textiles, paint, food, pharmaceuticals, cosmetics, and thermoplastic industries. A broad range of types of dyes exist, with over 10,000 synthetic dyes used in industry. The dye industry holds a very large market, with approximately 700,000 tons of dye stuff being produced annually. The textile industry is one of the primary users of these synthetic dyes, consuming up to 200,000 tons per year of the dye. And in addition to being the largest consumer of dye products, it's also the biggest polluter of dye-containing effluents. One heuristic for textile manufacturing is that approximately 10 to 15% of dye used in a textile process is discharged as waste. Textile plant wastewater is a current and ongoing issue, as can be seen in a 2017 National Geographic article reporting dye-stained dogs near a textile plant in India. The wastewater from textile plant is classified as the most polluting of all industrial sectors, considering the volumes generated as well as the effluents compositions. Dye-containing wastewater poses significant environmental threats due to decreased light penetration and photosynthetic activity, causing oxygen deficiency and limiting downstream beneficial uses such as drinking water and irrigation. Additionally, some dyes are highly toxic and mutagenic. As sustainable manufacturing processes gains increasing importance, a wide variety of treatment methods have been developed. The most conventional method is an absorption process using activated carbon. This technique provides an adequate removal efficiency of the dye, but is extremely expensive due to the regeneration process of the absorbent. In addition to this technique, multiple techniques have been produced by companies such as Snyder Filtration and BASF for the remediation of dye-containing wastewater. Before I introduce our group's approach towards dye wastewater treatment, I would first like to introduce what a coacervate system is. Coacervation is defined as the separation of two liquid phases in colloidal systems, where the bottom phase, or coacervate, is concentrated in the colloid component, and the top phase, or supernatant, is dilute in the colloid component. The first example of a coacervate system was demonstrated in the late 1800s by a Dutch biologist who found that after mixing aqueous solutions of agar and gelatin and letting the mixture settle, the mixture would separate into two phases after settling had occurred. Now, our group uses coacervates to extract dye using a batch procedure. Wastewater samples containing 0.2 grams per liter methylene blue were treated to determine the upper limit of absorption for our coacervate absorbents. As can be seen in our results, based on the drastic reduction in color from wastewater samples to treated samples, all coacervate samples have extremely high absorption maximum. Maximum dye absorption for our coacervate absorbents approach 400 milligrams of dye per gram of absorbent, which is 4 times as efficient when compared to conventional methods such as activated carbon. Thank you for watching. For more information regarding this project, please attend Wayne State University Student Innovation and Design Day on April 20th, 2018.